Hello everyone, welcome back to my channel. If you have been following me, you must have seen my previous video, and if you remember, the topic of my previous video was the basic difference between gram-positive and gram-negative bacteria. So if you have seen my previous video, you must already be cleared about the topic, means the difference between gram-positive and gram-negative. Now today our topic is related to the previous video. So our topic today is the mechanisms of gram reactions. So mechanism of first point is the acidic protoplasm. So if you are familiar with the word protoplasm, protoplasm, please don't mind my handwriting. It's obvious that it's not very clear, but I can't help it. So protoplasm basically means your cytoplasm plus nucleus. So what happens is, in gram-positive bacteria, your protoplasm is mainly acidic in nature. And let me remind you what we did while gram staining. In the first procedure was the primary staining. So in primary staining, what we use is, the dyes we use are the methylene blue and the crystal violet. If you don't remember, then you can go and check out my previous video. So the primary stain, what I've said is, the primary stain is methylene blue and crystal violet, which is basic in nature. So what happens is, the protoplasm being acidic in nature and the dyes being basic in nature, they have more affinity to the basic dyes, which happens to retain the dyes. So this is the first topic. You understood with the point that due to acidic protoplasm theory, means your gram-positive bacteria, your protoplasm of gram-positive bacteria is mainly acidic, while the dyes we used in primary staining are basic. So what happens is, your acid, obviously they will have affinity for the basic dyes, which happens to retain the dyes. So the the second topic is lipid content theory. As you know that in gram-positive bacteria there is less lipid as compared to the gram-negative bacteria. So after the application of mordant, there is a formation of diiodine complex, followed by your decolorization. In decolorization step, what we do is, we pour alcohol on this bilipid layer. What alcohol basically does is, you have to understand this point, alcohol basically dissolves or diffuses your bilipid layer, means your fat layer. So they basically breaks or dissolves your fats or your lipids. So when alcohol is poured on the gram-negative bacteria, remember there was high amount of lipids in gram-negative bacteria. So if there is high amount of lipid, obviously there will be high amount of breakage of these lipid membranes, including leading to increase in the pore size, through which this diiodine complex diffuses out. But in case of gram-positive bacteria, there is less amount of lipid content, so there is less amount of leakage of your diiodine complex through the pores. So this is your lipid content theory. Point is, it's a common sense. If lipid content is less, obviously there will be less pores, leading to less diffusion of your diiodine complex. Okay, so the third point is the cell wall permeability. I think you all are quite familiar with this point, because what happens is, in gram-positive bacteria, the cell wall of gram-positive bacteria is basically comprised of mucopeptide, which is also known as murine or peptidoglycan in nature, which is also known as murine or peptidoglycan. Murine or peptidoglycan in nature, making it stronger and thicker and further preventing the leakage of diiodine complex. But in case of gram-negative bacteria, it is total opposite, because the murine or your peptidoglycan or your mucopeptide content is very negligible, due to which it is weaker and hence releases the leakage of diiodine complex. So the fourth topic is magnesium ribonucleate theory. This theory is quite new, I think, and according to this theory, it states that the magnesium ribonucleate is present in gram-positive bacteria, whereas it is absent in gram-negative bacteria. So what happens is, during second step, after the application of mordant, there is formation of magnesium ribonucleate diiodine complex is formed in gram-positive bacteria, which is insoluble alcohol, while in gram-negative bacteria there is formation of only diiodine complex, which easily gets soluble in alcohol. So this was your topic. So as you can see, for reference, and there are two pictures. This is your gram positive and this is your gram negative. So these are your mucopeptide or your murine or your peptidoglycan layer. You can see that in gram positive bacteria, your peptidoglycan layer is thick as compared to the peptidoglycan layer in your gram negative bacteria. These circular structures, there are 3 layers, but actually they are not 3 layers. For understanding, we have drawn this in layers form. Okay, so this one is your peptidoglycan and this one is the peptidoglycan of your gram negative, and in addition to the peptidoglycan layer, the cell wall of your gram negative bacteria is much more complex than the gram positive bacteria. They have lipopolysaccharide region, they have outer membranes. So these are your outer membranes and lipoproteins, and lastly comes your peptidoglycan layer. So this is your basic difference between your gram positive and your gram negative bacteria. If you liked my video, don't forget to subscribe and like this video, so I can provide you a better video quality in near future. So please don't forget to share, subscribe and like it. Thank you.